We're about to solve these two linear systems by substitution. A linear system has two equations and two unknown variables like x and y. And to solve a linear system, you have to find the value for each variable that makes both the equations true. Sometimes you'll see the question say, solve the linear system, and sometimes you'll be asked to find the point of intersection. And this is one method for doing that called solving by substitution. This is how you do it. Let's start with the first one. The first thing you always want to do is label your two equations. And we just label them with 1 and 2, and usually I just put a little circle around it just to help it keep track and so it doesn't get messy. The very first thing you always want to do is make sure at least one of the variables in one equation is isolated. So that means it either starts with y equals or x equals or whatever your variable may be. Now in this case, in both of our equations, the y variable is isolated, which is going to make it really easy. But really, you only need one. So since I don't have to isolate any variables in this case, I'm going to move on straight on to step 2, which is sub in one of the equations into the variable of the other. So what we want is to have one equation with one variable instead of having two equations with two variables. So what I'm going to do is I'm going to take this, and plug it into the y value of this equation. So sub this, so I can just put equation 2 into equation 1. Okay, and it's going to look like this. So instead of y, I'm going to rewrite this part of the equation. Negative 4x minus 2, right? This part, instead of y, equals, and then I rewrite the rest of equation 1. 3x plus 5. And now the next part is simple. All I want to do is simplify this big equation and solve for the missing variable. I have one equation, one variable, so that should be easy. How I like to do is bring everything with the variable, with the x, onto the left side, right? So here I have 3x, so I'm going to subtract 3x from both sides. This is how I like to show it. Right, so negative 4x and negative 3x makes 7x, right? This kind of crosses out. Minus 2 equals 5, right? And now I'm going to bring this negative 2 onto this side. So in order to get rid of a negative 2, I have to add 2 to both sides. This kind of crosses out. And 5 plus 2 equals 7. So I can write negative 7x equals 7. Okay, and I already have a feeling what x is going to be. Divide both sides by the coefficient in front. So divide both sides by negative 7. Divide by negative 7. This crosses out. And 7 divided by negative 7. And that gives me x equals negative 1. Now, a lot of people get excited because they think, okay, great, I'm done. I found my x. And you actually still need to find the y value. So this is what we're going to do. We're going to take our value that we just found for the variable, x equals negative 1, and we're going to plug it into one of the equations. It actually doesn't matter which one. You can choose, and I'm just going to choose it and plug it into y equals, into the first equation. Okay, so I like to write it this way, sub x equals 1 into equation 1, and this is why I label it with a little circle. It's going to look like this. Y equals 3 times negative 1, right, plus 5. And now simplify it. Y equals 3 times negative 1 is negative 3 plus 5, and y equals negative 3 plus 5 is equal to 2. Now, it's not enough to just have, part of the answer here, part of the answer here. You have to answer the question the way that it was asked. So if you were asked, find the solution, then you could say the solution is x equals negative 1, y equals 2, or whatever the variables are. But in this case, we were asked for the point of intersection, and we would just say the POI is negative 1, 2. The x value goes first, negative 1, and the y value goes second, and this is actually like the point of intersection between those two lines in the beginning. Just found our point of intersection, and we can do a mental check to see if it works for both equations. But if this is a test, you'll very likely be asked to do something called a left side, right side check. And a left side, right side check is a method to make sure that your point of intersection or your solution works for both equations. So let me show you how to do it. So we're going to do it for each equation. Let's start with equation 1. You do a little chart. You don't really need to go all the way like this, but and I like to put left side for LS for left side and RS for right side. And you write out the left side of the equation. Here's just 1. And the right side of the equation, 3x plus 5. Now, this might seem like overkill with these equations that are already simplified, but sometimes you're going to have a more complex equation. Okay, so now I plug in the values that I just found. So for y, I plug in 2. So this is equal to 2. And for the right side, it's 3x plus 5. So I plug in negative 1 for x. So equals 3 times negative 1 plus 5. Negative 3 times 3 times negative 1 is negative 3 plus 5, and negative 3 plus 5 is 2. I actually just did this, so I know it should work out. It usually works out for at least one equation, even if you get it wrong. So if I have the same number after simplifying both sides, and the left side equals to right side, so it gives me an idea that I'm doing pretty well. Now let's do the same thing for the second equation. You have to kind of follow the exact same method, right? I write out my left side and right side. Left side is y, the right side is negative 4x minus 2. Now plug in my values. The y value is 2. And on the right side, I have to plug in the x value. So negative 4 times negative 1 minus 2. Negative 4 times negative 1 is positive 4. And then I have minus 2. And 4 minus 2 is equal to 2. Okay, so again, here, let's just do it a little higher. The left side equals right side, which tells me that these two values, negative 1 and 2, works for both equations. Look at the second linear system. This one's going to be a little bit different because it's not written in that y equals mx plus b form. It's written in standard form, which means I actually have to isolate a variable. So let's start the same way. We're going to label our equations 1 and 2. And now we need to isolate one variable in one equation. Okay, and it helps to kind of have a look and see which one would be the easiest to isolate. And here I can see that y from equation 1 would be the easiest to isolate because I'm not going to have to divide it by anything. In order to isolate a variable, I need to bring everything from one side to the other side and just leave the variable here. And in this case, I have 3x plus y. I'm going to subtract 3x from both sides to cancel it out. And over here, it's going to be minus 3x. Okay, so my new equation is going to be y equals to negative 2 minus 3x. And once I isolate it, I actually like to label it as equation 3 because it helps me keep track of these equations. Once one variable is isolated, I need to plug this in or substitute it into the other equation into the space of that variable. Sub in or substitute in equation 3 into, I can't put it back into equation 1 because that's the one I just rearranged, so I have to do it into the other equation, into equation 2. And it's going to look like this. So here, instead of y, I'm going to write the right side of this equation, and it's going to look like this. 2x minus 4, and then instead of y, I'm going to write in what I just isolated, negative 2 minus 3x, close the bracket, equals 8. You see, so that's the same as equation 2, but instead of y, I wrote in what I just found for y in equation 3. So this will take a little extra step than the last one because I need to simplify this equation before I can solve for it. So I need to multiply everything by negative 4, so distribute everything into the brackets. And it's going to look like 2x. Now I have negative 4 times negative 2, so plus 8 plus 12x. And then on this side I have equals 8. Now I combine my terms, right? I have the 2x and the 12x. I combine them into 14x plus 8 equals 8. Subtract 8 from both sides, right? Want to bring this to the other side, but I kind of like to show it like this because I'm a teacher. So 14x equals 8 minus 8 is 0 because this crosses out. And if I divide both sides by 4, you can already see, just going to do it a little bit on the side, x equals 0. Okay, so I got one of my variables. And now I need to plug it back into one of the equations in order to find my y. It doesn't matter, you could choose 1 or 2, but the equation I'm going to choose is 3 because in this case, I already have the y value isolated. Y equals to negative 2 minus 3x by x is 0. Simplify, so negative 3 times 0 is 0. And so y equals to negative 2. And again, I can't just leave my answer partly here, partly here. I have to state, if the question asks for the point of intersection, I have to say the POI, or point of intersection, is x value goes first, 0, y value goes second, negative 2. And that's it. That's all you have to do. So again, you know you did it right, I know you did it right, but you'll likely be asked to do a left side, right side check for both of the equations to prove that you did it right. So let's do that for each equation. So for equation 1, let's do our left side, right side check. Left side, right side. Left side, I have 3x plus y. And on the right side, I have negative 2. Okay, so let's plug in those values. So x is 0, so that equals to 3 times 0, and y is negative 2. So I could say plus negative 2, or I could just write minus 2. And that is 0 minus 2, and that is negative 2. So for equation 1, if the left side equals right side, that is a good thing. And now let's do the same thing for equation 2. Equation 2 is 2x minus 4y equals 8. So on the left side, I write 2x minus 4y, and on the right side, I write 8. Now I sub in the point of intersection, x equals 0, y equals negative 2. So here I would write 2 times 0 minus 4 times negative 2. 2 times 0 is 0. Negative 4 times negative 2 is positive 8. So the left side equals 8, and the right side is already equal to 8. So again, I can say that left side equals right side. I am good to go. So again, these are the steps for solving a linear system by substitution, also known as finding the point of intersection, or POI. Screenshot these steps for later and check out these tutorials for more examples. See you next time.